Okay, so question 9 is all about the binomial probability distribution, and we've got some dice to play with. Okay, the first part of this question asks us to write down the conditions that need to be satisfied. Do you know how many conditions there are? Well, the answer to that is that there are 4 of them. And the first one is to do with the number of times that we repeat the trial or experiment, and it has to be a fixed number of trials. So that's the first condition. The second condition is that we can classify the outcomes as either a success or a failure. That doesn't mean to say there have to be only 2 outcomes. If we're looking at a dice, for example, then success and failure, there are actually 6 potential outcomes that we might get when we roll the dice each time. But we're classifying these ones into success will be that we roll a 6, and the failure will be that we roll anything other than a 6. So it's classified into success and failure. The third condition is to do with the probability of success in each trial. That has to be fixed. And the most easy one to forget, I think, possibly for most students, is the fact that each trial has to be independent of all of the others. So if we can satisfy all of those conditions for any particular situation, then if X is the number of successful trials, then X is distributed as B, binomial distribution, with N and P. So that's the answer to the first part. Now I've been asked to see what the probability of getting between 5 and 10 sixes are, or is rather. So for probability between 5 and 10 sixes, I need to think about what probability distribution I'm going to be using. There's a bit of a clue here. If you think about each of the 4 conditions, then as long as it's a fair dice, which we're told it is, and nothing changes as we go along, then all the conditions are satisfied, and we can use the binomial distribution. In this case, N is 30 and P is 1/6. So what I'm going to do is show you initially what the distribution actually looks like. So this is B 30 1/6, and you can see the height of each of the little red bars represents the probability of each of these values of X. X could be as small as 0, we might get no 6s, or as big as 30, we could possibly get 30 6s. So these probabilities here are the probability that X equals, and this should have been a little x here. These are the little values of little x, and these are probabilities that our random variable takes these little values of x. So we want to know what the probability is of rolling between 5 and 10 sixes is. So we want to add up all of these numbers. Now, if you are if you have a graphical calculator which has the capability of calculating that for you, then that's the quickest way to find the answer. But my calculator has got what is called the BCD, binomial cumulative distribution, and that tells me only the probability that X is less than or equal to some particular number. So if I want to use this facility on the calculator, I need to decide how I'm going to find the answer to the question. So I need a bit of space here. So what I'm going to do is I'm going to say that the probability of getting between 5 and 10 sixes is equal to the probability of getting less than or equal to 10 sixes minus the probability of getting less than or equal to 4 sixes. So the probability that x lies between 5 and 10 is the probability that x is less than 10 minus the probability that x is less than or equal to 4. When you do the calculations, the first calculation is 0.99325. The second is 0.42434. So the final answer is 0.5689 using 4 significant figures. Hopefully you got the same answer. If you did, well done. And we'll move on to the next question.